I'm Cole Christensen.
And I'm Andrew Wada, and this is our final project for ECE 3710.
We present to you Weather Bro. Weather Bro is a handheld device that takes in readings from the environment around you and gives you them on a screen so that you know what the environment is like around you. This is a general schematic of our device. We have two sensors that read the environment around you, the BMP280 and the SGP40. The BMP280 reads the temperature, humidity, and pressure. The SGP40 reads in the air quality. And these communicate with the STM32 microcontroller through the I2C. And when they input to the microcontroller, it outputs the data onto the LCD screen, the same one that we've used in our labs. And the user buttons, there are 4 user buttons used, a green, blue, yellow, and red. And each one, when pressed, displays different data onto the LCD screen. And then we also have UART communicating with the PC, with the microcontroller and the PC. And when inputs are pressed on the keyboard, it displays different data through UART onto the terminal.
For our final project, the general component overview is as follows. We have multiple components interfaced together on our microcontroller to make our Weather Bro sensor work. The first one is our SGP40. This sensor detects the current air quality as an amount of volatile organic compounds within the air and outputs the signal to our microcontroller. Our next sensor is the BMP280. This one will detect the current air temperature, air pressure, and air humidity and output those parameters back to the microcontroller for processing. We have 4 user buttons connected to our microcontroller. Out of the 4, each one, when you press it, it will set a state within the microcontroller to determine which parameter it needs to be outputted to the LCD. Yellow is for air pressure, blue is for humidity, red is for temperature, and green is for air quality. Now, we have a PC. This is not necessary. However, if the microcontroller is connected to a computer, or a laptop, using PuTTY, you can input commands and receive data back over UART for if you want to connect this microcontroller sensor up to a computer and receive data that way to process it with some sort of other program. We have it set up so that it will accept 5 different commands. If you enter T, it will give you the temperature. If you get P, it will give you the pressure. If you give it Q, it will give you the air quality. And if you give it A, it will give you all of them at once. All right, so this system, for the software side, we are interfacing between the different components using 2 different serial communication methods, as well as a bunch of just various GPIO methods. To interface between the SGP40 and the BMP280, we are using a shared I2C bus. We are using I2C over a USB bus controlled by the ST Link programmer in order to read data over UART onto the terminal, which is what we'll demonstrate next.
Okay, so this now is a demonstration of the terminal through PuTTY. This is how the microcontroller communicates. It uses UART. So if we click into the terminal, we have, if you press lowercase q or uppercase q, it displays the air quality. And then if you press T, lowercase or uppercase, it will display the temperature. P, lowercase or uppercase, will display the pressure. And H, lowercase or uppercase, will display the humidity. And then lowercase or uppercase A will display them all at once on the terminal. And you can do this as many times as you want. Okay, so this is our hardware design. We have the STM32 microcontroller right here. And then on the left, starting, we have this is the SGP40. This is the air quality sensor. And then right here, the small square, that is the BMP280. That is the temperature, humidity, and pressure sensor. And these two components share the same serial data and serial clock lines. And then we have the four input buttons that change the screen based on which one you pressed. So right now it is displaying the temperature. If we press the yellow one, it switches to the air pressure. If we press the blue, it switches to the humidity. And then if we press the green, it will switch to the air quality, displaying all these values clearly for the eye to see. So if we switch it back to temperature by pressing the red button, if I place my finger on the temperature sensor, it begins to warm up from the warmth of my finger warms up this sensor, which now brought it up to 24 degrees Celsius. You can breathe into the air quality sensor and it changes. As you can see, the air quality changes because it senses the CO2 for my breath. And you can see if I also touch my finger on it, the humidity changes. Once again from my finger. If you take it off, it begins to go back down.
So as for our final project, for a final note, we want to go over some things we feel we did well and some things we did less than well. To start off with what we think we did well, our sensors ended up being way more accurate than we expected, down to only a couple, like 2% error for pressure and almost right on the dot for temperature, no matter what.
Another thing that we did really well was UART was implemented fast and worked great, and there was not very many problems with that.
So our I2C implementation, I think it was a great strong point to our project because any new sensor we want to add, as long as it's I2C, it'll take less than 15 minutes to implement it onto our existing code and get it working.
Some things, we also want to talk about some things that we would want to change if we did the project again. One thing we thought of was implementing a wind speed sensor also to add to the array of sensors that we would have in the device.
Another thing is our current design uses 4 separate buttons that simply set the display to output a certain thing, but it gets really large fast as you start having more and more different parameters to have, and it's kind of clunky. So something I would definitely change in the future is have a single button that toggles through states instead of having multiple buttons that only have a single function each.
Another thing is our UART terminal, it does display on the terminal the values, but we didn't implement it so that when you select a value on UART, it would also change it on the LCD screen that comes out of the microcontroller.
So another thing is we originally wanted to make this device portable, but we ran out of time to design a housing for it. So if we had more time to work on it, we would definitely build a 3D printed frame for everything to fit in.
Also for the air quality index, to actually convert it to the correct value was a lengthy process. And so we don't have the completely accurate reading on there. But if we were to do it again, we would make sure that we went through the process to get the correct reading.
Yeah, our current air quality index it's less of an index and more of a fixed scale readout. If we were to do it correctly, we would change it so it would fix around an average value and give a relative air quality versus just giving a scaled raw version of what the sensor is reading. All right, and thank you. This was our final project for ECE 3710.
Weather, bro.
Weather.